So today we're doing 5.2.2. What if it's more complicated? Computer simulations of probability. If you toss a coin 10 times, what is the probability of getting three or more heads in a row? If an airline overbooks a certain flight, what's the chances that more passengers will show up than the airplane has seats for? When 67 people get cancer in 250 homes in a small town, could that be due to chance alone? Or is polluted well water or some other cancer causing source a more likely explanation for the cluster of cancer cases? So, in this first paragraph right here, they are talking about real life of examples of probability, how we use statistics and probability in real life. And so that's important so that we know really the math itself is not unique just to a textbook, but we use it in everyday life. And so it continues saying, when the mathematics becomes too complicated to figure out the theoretical probability of certain events, statisticians, people who do statistics, that's their career, that's what they do for a living, they often use a computer simulations instead. So if it's too hard to do by themselves, they're going to use a computer to help them out. Many simulations require the use of random numbers. Random numbers have no pattern. They cannot be predicted in any way. Knowing a random number in no way allows you to predict the next random number. An example of a random number generator is a standard number cube, which randomly generates numbers from 1 to 6 when you roll it. So if I roll a die right now, which is 1 in a pair of dice, whatever number comes up, that's a random number generator. Because if I get a 2 the first time, I am just as likely to get a 2 the next time I roll it as I was the first time. It doesn't change. Some people might try to convince you otherwise, but it's still the same probability. Complex simulations like modeling the weather, traffic patterns, cancer radiation therapy, or stock market swings require tens of billions of random numbers. For those simulations, a large computer, it can be running for hours or even days is needed. However, many simple simulations can be done with classroom technology. Problem 534, we skip, has 3 different games. We use a random number generator from 1 to 20. I skip this one and I go straight to problem 535. And you're going to see why in just a little bit. So it says Janelle is going to babysit her nephew all day 5 times this summer. She has the idea that one way to entertain him is to walk to McBurgers, kind of like McDonald's, but they can't write that or else they'd have to pay McDonald's money. So she's going to walk to McBurger for a kid's meal for lunch each time. So each of those 5 days, she walks down to the local fast food place and she's going to buy him a meal, one of the kids' meals. The kids' meals comes packed randomly with one of 3 possible toys. She wants to know what's the probability that they're going to get all 3 figures, all of those toys in the 5 trips. So it has us where we can explore using the student tool, and we're going to do that in just a moment. However, I want to make sure that we understand what's happening first. So it says we're going to call the toys number one, number 2, and number 3. So there's 3 different ones. That one right there is 1. The green one is blue, or is 2, and it should have been blue, huh? And then the blue one is going to be number 3. Use the random number generator to simulate the 5 trips to McBurgers. And then we have to answer if we got all 3 action figures. So I'm going to click. Now, when you go and do this on your own, I want to make sure some of the things that some of the students struggle with, they accidentally clicked the E tool up here. Don't click this one. Totally different number set. You want to make sure that you have 535 when you're clicking this, okay? So we're going to click, and A, we're going to do together just so that I can make sure that you understand what we are doing. So what's going to happen is in a moment, I'm going to click this, and then we're going to write it down. We're going to write it down. Oh, fiddlesticks, that's not what I wanted. Oh, fiddlesticks. I didn't bring up my viewing thing. Hang on just a second. All right, I got my view, my doc cam going. Sorry about that. I don't know. It probably just took a second for me to get it up, but it's right now. This whole thing's being kind of ornery. Technology is not my friend today, but that's okay. We are going to persevere. So I'm going to be writing right here. I'm going to be writing down where when I click it, I'm going to write down what we get right there. So here we go. So we got 1. So you should be writing this down with me because this one here should be the same. 3. So trip number 2, we got action figure number 3. 2. I'm going to write 2 as my third trip. 3 as my fourth trip. And 1 as my fifth trip. So looking at right here, so that's what I have. Trip number 1, we got toy number 1, trip 2, toy 3, trip 3, toy 2, trip 4, toy 3, trip 5, toy 1. And in this case, we did get all 3. We have 1, 2, 3. So I did get all 3 toys.